Good afternoon, students.
Good afternoon, teacher.
Sit down, please. So, how are you feeling today?
Fine.
Okay, let us start our lesson. And first, we should define the date. Today's date is 13th December of 2016. Please write down the date.
Because as we study this topic on logarithms, I want us to come back and see what we're learning and how it is related to the date that we have written.
Let me start with some simple questions that are you supposed to answer. The first question is this true or false? Who can answer?
It's false. It's false.
Who says it's false? Ilona, say please why.
Because 8 is power, so it's not 16, it's 64.
It's 64. So what should be in this place of 8? 4. Yes, you are right. So the next question is
it true or false?
It is false.
It is false.
Who can tell me why it is false?
There should be 3.
X should be equal to 3. Very good.
True or false?
False.
Zarima, why it is false?
Because x should be 3.
Louder please.
X should be 3.
X should be 3. Let's check. Yes, you are right. Very good. Going to learn
How to find
x in such kind of equations.
Yes.
Very good. Very good. And please write down our topic today is logarithms and its properties and what was the purpose of our lesson. The first thing is to understand the idea of logarithms and then determine rules of logarithms, those properties like sum, subtraction and exponent of logarithms.
Just to mention the second purpose of the lesson here, we want to see how to add logarithms, how to subtract logarithms, and also how to raise logarithms to a certain power. We're going to give you an activity later on that will enable you to prove the properties of logarithms. In that activity, you will work in groups, and we shall direct you what to do.
So, about learning objectives, we have 2 learning objectives. First is understand that if, you can say, and the second one is to determine the rules of logarithms. It's very similar to our purpose of our lesson. And first of all, to understand the logarithms, we need to recall the exponential function. The general form of exponential function is f from x is equal to b to the power of x. So, in such kind of equations, we are asked to find what will be the meaning of our function. Am I right?
Yes.
Okay. So then, we can skip to the second part is, we will be asking, given the result of our function, what is the exponent? It's like this. 25 is equal to 5 to the power of x. 5 to the power of what? 2. So, we are coming to next question. For example, we have a function y is equal y is equal to 10 to the power of x. So, to find x, we need to define a new function. And that function is logarithm. Let us pass to the definition. The definition looks like this. A logarithmic function to the base a, where a should be, must be greater than 0 and not equal to 1, is defined as it's shown below.
If y is equals to the log of x to the base of a, then that log function can be written in exponential forms. So the first objective of this lesson, as you can see from what I just wrote here, is to understand the idea of logarithms. Now, since you have worked with exponents, in today's lesson, we want to see how to relate exponents and logarithms. And if we are given an exponential function, is it possible to write that exponential function in logarithmic function, as a logarithmic function? Okay? The idea shown here is that if y is equals to the log of x to a certain base of a, then x is equals to a to the power of y. Okay? Write that down in books.
So this kind of form is called logarithmic form, and this kind of exponential form. They work with the same variables. So that how do we read it? The log of x to base a is equal to y. And here is, x is equal to a to the power of y.
Somebody read for me this equation I have written here. What is this equation? Read for me this equation.
Of 100 to base 10 is equal to 2.
Correct. The log of 100 to the base of 10 is equals to 2. Now, in the next lesson, as Idos will show you, we want to write this expression from logarithmic form to exponential form. I just wonder, how do I convert this into log form? Think of 100, think of 10, and think of 2. Is there an exponential function or exponential equation that you can write that can relate this log into exponents?
100.
Can you come and show us? Come forward and write for us. Thank you, Amina.
We can write like 10 in the power of 2 equals to 100.
Well done. That's correct. That is absolutely correct. Okay? We call this the base. You can see that's also the base of the logarithm. And this is the answer. This answer comes in the power section. And this is the log, which is the log of 100 to base 10 is equals to 2.
From logarithmic form to exponential form, and from exponential to logarithmic. The first one is converting to logarithmic form. For example, we have such an equation, and we can say that logarithm to the 16 to base 4 is equal to 2. So you can see that 4 comes to the base, 16 comes to logarithm, and exponent comes to the what does logarithm mean, to what it equals to the power of minus 3 is equal to 1 over 8. Very good. So you can see where does 2 go, where does minus 3 go, and where does 1 over 8 come. And what we need to mention is that converting an exponential to log form, we need to notice that exponent becomes what the log is equal to. Did you understand? Such an equation like logs are equal to the exponents, like you have seen from previous example. With this in mind, we can answer questions about the log. For example, log 16 to the base of 2. You need to think about 2 to the what is 16? 2 to which power is 16? 4. Very good, Ilona. The next question is, for example, we have such this logarithm. Olga, please.
Minus 2.
Minus 2. How did you find it?
Because 3 in power minus 2 will be 1 or 9.
Excellent. Excellent. Okay, next question. If you have irrational logarithm, we have a hint. We should rewrite any radicals as rational exponents.
Maybe
Yes,
it will
Lola?
be 1/2.
1/2. Very good. How did you find it?
We
Can you show us over there on the board, please? Try this one.
Equal to 2.
It is equal to
2.
2. Very good. Next one.
It is equal to 5.
It is equal to 5. Very good. Next one.
It is equal to minus 2.
How did you find it? We don't have brains. Okay, when you guys don't have base, it is supposed to be that base is 10.
Okay? When the base is not defined, then the standard base is given as 10.
So if you see such equation as, it means or also it can be written like examples.
Yes.
Did it make sense? Very good. So what is the answer in the last question?
Minus 2.
Minus 2.
2.
Very good.
Alright. Now we have come to the part where we call essential questions. And these are questions that I want you to think about. Okay? You may not have the answers immediately, but I'd like you to discuss with the person seated next to you and try and come up with a solution. How do exponential functions? And Idos has talked about exponential functions. For example, f of x is equals to a to the power of k, or y is equals to 2 to the power of 5. That is also another exponential function. Okay? How do exponential functions model real-world problems and their solutions? So I have shown you a graph here of an exponential function. You notice as x increases, what happens to the value for y? It also increases, but then it does not increase in a linear format. It increases in an exponential format. So discuss with your partner for 1 minute, and then after this I'm going to hear some of your solutions. Okay? Manage. And even if you don't manage in the next 10 minutes, isn't it a problem? Because you're taking a video for editing.
Solution with logarithm, I think. What do you think about this?
Alright. Ladies up. Let's hear some of your solutions. Real world problems. What did you come up with?
It seems that exponential functions can be used in science and statistics.
Correct. She mentions that exponential functions can be used in the field of science and possibly also in statistics. That is a good response. Can somebody try and make her answer more specific?
Maybe exponential function can be used to count rising of country rivers.
Population.
Yes, of population.
That is a very good response. When we look at population growth, we see that in countries For example, in this country, Kazakhstan, the population 10 years ago was, what was the population of Kazakhstan 10 years ago?
16 million.
Yeah? Currently, I know it's 17 million.
Nearly.
Currently, it's 17 million.
10 years ago it was nearly 14 maybe.
14.
14, 15.
What about 20 years ago, the time we gained independence? What was the population of the country then?
It was very small.
It must have been very small. I'm not quite sure of the facts, okay? But then, if you compare the population then and now, you surely will see a significant difference in the 1990s and in the year 2016, okay? Ilona, you had a solution?
Maybe we can also use it in big companies to organize data. For example, to create a stronger function to compare whether the amount of people buying new products rises in the same way that their income rises.
Oh, it's very interesting.
Very good.
In some applications of logarithms in life, we know that logarithms are applicable in many areas. And here we can see that music, the frequencies that sound makes, can be used to model logarithmic functions. We can also see that earthquakes, for instance, the measurement of earthquakes is done using Richter scale. And if you move from one Richter scale to the next, again, that function resembles an exponential function. So we have so many applications in our real world of how we can use exponential functions.
So one of the best examples, if we can differentiate mathematics with biology, and we can easily say that logs can be used in biology. For example, when we calculate pH measurement of any compounds, or for example in music, logarithmic scales are used to describe sound intensity or frequency. And also, as Descartes and Jacob Bernoulli, they have invented a logarithmic spiral or growth spiral, how Jacob Bernoulli called it the marvelous spiral. It can be seen in nature. For example, you see, in the structure of these organisms, the spiral is used.
All right, another use of logarithms, we can see that the logarithmic spiral that I just talked about can be seen in cyclones. You know what a cyclone is? As you can see here, we have the epicenter, and we have this model moving in that cyclic manner. And so this is a possibility or a way in which the log function is seen in nature. At the back of your class, there,
Look here, please.
you can see a painting that also shows that cyclic nature. And so logarithms can be applied in so many ways in the world of today. Okay? Also galaxies, planetary systems which are far away from ours, resemble the logarithmic model that we are discussing today. Okay? Good.
Okay, we've talked a lot about the logarithms, the idea of logarithm, and how it can be used in our real life. But now we need to practice a little bit. So that's why we have a team.
Alicia, come forward. Please, okay?
So with this 3.
Good, let's clap for him.
Log of y in power 5
will be 32. Do you agree?
Yes.
Clap for her. That's right.
The next exercise will be done in groups of 2 and 3 people. I think. Well, we have only 9.
We have 9, so
We have
3
9.
groups.
3
3
groups
groups of 3.
of 3. These 3 students will be in first group. These 3 in second, and Alem, Olga, and Nina in third group.
So this activity, we want to prove the laws of logarithms. Okay? We'll give you an activity to do, and afterwards you're going to come forward and show us how you prove the law of logarithms. So group 1, we're going to use that. Group 2, this is yours. Group number 3, we will work on that. Okay? Please take 3 minutes to answer those questions on that activity. Okay,
Yes,
just for you. What is the question? Because they're too small.
First of all, you should fill in this spaces so that you can prove this kind of property, and you write the proof.
Okay, now
And you
let me come round so that I don't block the camera. Try to answer these questions. We're told here the log of x to the base of r is equal to p. Can you write this expression in this form? R to the power of is equal to x. Very good. Okay. Now the next question. Raise this expression to the power of n. So you're going to write to the power of n there and to the power of n. Just in this step.
You should just write both expression in mixed form. Next. Yes, like this. And then
Well done.
I'm going to prove
Is it
this
possible for you to write this in logarithmic form?
property.
I will give you an example. Look at it.
Property,
You're
so
told
that you can
that,
present it to other groups.
10 to the power of 2 is 100. Is it possible for you to write this in that form?
You can also divide your roles, like one is doing this part of the exercise, and you can also start off proving. Nice. You're on the right way. Very good, very good. P times n. Very good, yes. And then what are you supposed to do next? You write your expression in logarithmic form. Suppose that x to the power of n is a one thing. It's a one number. Okay? Yes, very good. And it's equal to? Well done. Oh, first to the next
We
page.
need to move on. So could we have the first group present their findings to the rest of the class? Okay, come forward. Come forward.
The base on f is equal to log of x to base on f plus log of y to base on f.
Well done. So, our first group has come up with the next property. Log of x times y to base r is equal to the sum of log x to base r plus and log of y to base r. This is a property, the first property of sum. Sum of logarithms. The next group, please.
Of x divided by y in the place of r is equal to p minus q. So then we replace p to log of x to base on r, and same with q. Then we have, therefore we can write this property.
Property
Yes.
of subtraction.
Yes, of subtraction.
Okay. Do you have any questions to share to his group?
No.
Does this proof is clear?
Yes.
Okay. Thank you, Richard. Sit down, please.
Clap for
Okay. Let's clap for Richard and write down the next properties that we have proved. It is similar to the first one, but we have not a product here, but the division x to y, and it is equal to logarithm of x to base r minus logarithm of y to base r.
The log of x in the power of p to the base n is equals to p multiplying log of x in the base of n.
Okay, very good. Do you have any questions to the third group, to this proof? Was it clear for you? Okay, let's clap for them. Sit down, please. And let us write down the third property we have learned. Third property does say that if you have logarithm x to the power of n to base r equal to n times the same logarithm. Did everybody write down?
Yes.
Now let us continue our lesson.
Okay. Before we continue our lesson, I'd like us to look at one last rule. Okay. As we can see, we have talked about these three rules. One is called the addition rule of logarithms. And if you recall, if you look at the objectives of the class today, the first objective was to look at the sum of logarithms. And so this is the sum of two logarithms. If you're adding two logarithms, like the log of x plus the log of y, all we have to do is to multiply them, and remember the base must be the same. Okay? Then we have the subtraction rule of logarithms. We have two logarithms with the same base, and you have subtraction. Then we divide x and y together. And lastly, we have the power. If the log of x to the power of n base r, if you want to write it in a different way, this can be written as n log x to the base of r. Okay? Now, there's one important rule that I want us to do it together as a class. We are going to use a smartboard, and I want somebody to come in front and write down the solutions with the help of the class. I'd like somebody to come and write all these expressions in index form.
A volunteer, please.
Write those expressions from logarithmic to indices. Alicia, come forward. There you go. Thank you. Well done, Aida. Thank you. How do we make x a subject? If z times x is equals to y, let me continue from here. Then x is equals to
Y over
y over
z.
z. But then, what is x? What is x in the original equation?
It's logarithm AB.
The log of, this implies the log of b to the base of a, which is x, is equals to, what's the value for y? The log of b to the base of c. And What is the logarithm of a to the base of c? Correct. Okay? And we call this the change from base to number.
Yes, and this is the fourth property of our lesson today. Please write down this fourth property.
Now, there is something that we can deduce from what we have learned. Because we know that if we are given an equation in exponential format, we can write it in logarithmic form. So we can see that the log of 1 to the base of a is 0 because of what? Who can give me the reason for that? Why is the log of 1 to base a equal to 0?
Because
Yes.
any number in the power of 0 equals to 1.
Correct. Correct. Any number, for example, a to the power of 0 is equal to 1. Next, who can prove for us that the log of a to the base of a is equal to 1?
Because every number in the power 1 will have the same equal.
Will be equal to the same number. Correct. Give me an example.
For example, 2
To the power of?
1 will
Yes.
be 2.
Exactly. 2 to the power of 1 is equal to 2. Okay? Well done. And the last one here, because we know that the log of a base a is equal to 1.
And the third law, power law, we can conclude that logarithm of a to the power of k to the base of a will be equal to k multiplied by logarithm a to base of a. But we already know by the phi property that it is equal to 1. That's why we have the equal to k.
Based on what you have learned, the rules of logarithms, how to change from exponents to logarithms, how to change from logarithms to exponents, I'd like you to create just one question for your deskmate, okay? For your classmate. The person sitting next to you, create one question and make it as challenging as possible using the rules of logarithms, okay? Make sure you know what the answer is, because afterwards you're going to mark the work for your partner. I'll give you about a minute to create the question and another minute to exchange and to do the question together. Okay, time to exchange the questions. Partner. Okay, now on your desks you have this instrument. What is this? Calculator. I just want to show you how to use the calculator to answer logarithmic questions and which buttons to press. If you have questions related to, you all have these calculators with you. Now, you notice we have two buttons in the calculator. One is written log. We use this button to calculate any expression that has a standard base of 10. So, just like your teacher mentioned, if the base is not written, then the standard base is 10. I'd like us to work out this question here, the log of 100. So we're going to press this button log, and then type 100, and then close the bracket. What is your answer? 2.
Answer?
Of course,
Did I get
the
that?
answer is 2 because the base is 10. We know that 10 to the power of 2 is 100. Okay? Let's do one more question. The log of 42. The log of 42. What is the answer? 1.632. Okay? we want to check whether this rule is correct. Okay? Because we have the answer of 1.623, we're going to say 10, without removing the answer, 10 to the power of, the power is here, 10 to the
Yes.
power of answer is equals to 10 to the power of 1.623 is equals to 42. That is because if 10 to the power of 1.643 is equals to 42, it means the log of 42 to the base of 10 is equals to 1.623. Okay? Lastly, I want to show you how to use this logarithmic button on your calculators. We use this button to work out questions that the base is defined. For example, the log of 32 to the base of 2, we're going to write 2 there for the base, and in there, where we have brackets, we are going to put in 32. So put in 32 there.
Right arrow. Arrow, 2, and then arrow.
2.
You get it?
Is it clear?
Arrow.
We're going to use clickers for a small quiz that I want us to
Assess.
answer. Call it like formative assessment, okay? The same thing.
Okay, guys. You have this kind of pictures. Each student has different picture, and you can see that you have like letters here. A, if you turn it like this. B, if you turn it like this. C, and then D. You'll be given questions on the board and given 4 answers. A, B, C, D. According to which answer do you choose, how do you solve the equation or exercise, you will choose one answer from A, B, C, D. And according to which answer do you choose, you should show your picture so that the letter you have chosen will be above. For example, if I choose D, here, do you see this D? I show that D is above. If I choose A, which is here, I should place my picture like this. Did everyone understand? So who has the answer? Please show your cards. To us. Don't shout and don't say it loud the answer. Just show the cards. In that position, already have some answers.
Good. Good. Okay. All right. Good. So the correct answer here is C. The correct answer is C. And most of the students in class got it. Okay? Whereas,
Okay, guys, the next stage is differentiation questions. You are supposed to solve only 3 questions of this given 9. You'll be given this kind of cards. And you're supposed to choose only 3 of them and solve them, please.
so choose any 3 questions from these 9 questions that we have given you. Only 3 questions of your choice. Okay? We will give you 5 minutes.
Exchange with our copybooks and check the right answers. Just put plus or minus. Plus if the answer is correct and minus if the is wrong. Okay, students, at the end of our lesson, we have known what the logarithm idea is, and we have asked to give your opinion on our lesson. First of all, you need to answer some questions like, what did you understand from our lesson, and where do you need more explanation? Please, go on. Okay, now, thank you a lot for writing these essays, and I want one volunteer to come up to here and share your opinion with your classmates about our lesson.
Tell us what you understood and possibly where you need more explanation. Let's have one person to come in front and share with us what you understood. Ilona?
I understood what is a logarithm and where it can be used. However, I would like to know more about properties of logarithms by doing practice tasks.
Thank you so much.
Thank you. So, and at this point, I